Hello guys, welcome back to my YouTube channel. So today we are going to solve day 27 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 1514, path with maximum probability. Okay, so in this problem you are given an undirected weighted graph of n nodes represented by an edge list where edges of I is equal to A of B is a undirected edge connecting the nodes A and B, okay, with the probability of success of traversing that edge. Okay, so we have given two nodes start and end. We have to find the path with the maximum probability of the success to go from start to end, and then we have to return its success probability. Okay, so if there is no path from start to end, then we have to simply return 0. Okay, so see this example number 1 here. So n is equal to 3. Okay, so in total we have 3 vertices, right? 1 2 3, right? And these are the edges. So 0 to 1 there is path, and this is undirected graph, so simply means that 0 to 1 we have one path, and from 1 to 0 we have also one path. Okay, 1 to 2 we have path, and 2 to 1 we have one path. Okay, and this is success probability given to us. Okay, so if I want to move from 0 to 1 or 1 to 0, this is going to be my success probability. Okay, and we have to start from this vertices, and we have to end at this vertex. Okay, so if I just go from 0 to 2, okay, then what is the total probability that I am going to use is 0.2. Okay, this is the total probability that I have. Okay, so now if I follow this path 0 to 1, then 0.5. Okay, and then again I go from 1 to 2. Okay, then again 0.5. Okay, if I follow this path, this and then this path. Okay, so if I just multiply it, then the total probability is 0.25. Okay, so here I have highest probability, right? So I have to return this. Okay, so 0.20 is less than 0.25. Okay, so here there are two paths from start to end. One having a probability of success is 0.2, and the other has 0.5 into 0.5, 0.25. Okay, so now let's see how we are going to solve this problem. Okay, so yeah, let's pick the same example. Okay, so number of nodes are 3. These are the edges. Okay, and these are the success probabilities given to us: 0.5, 0.5, 0.2, and we have one start node and we have one end node. Okay, so what is our objective? So we have to find the path from node 0 to node 2 that maximize the probability of success. Okay, so here first step is going to be the graph construction. Okay, so we are going to first construct the graph as an adjacency list. Okay, so from 0 I can move to this vertices, right? I can move to this node. Okay, simply. So 0 to 1 if I move, then this is going to be my uh, probability, right? See here, 0 to 1 if I move, this is going to be my probability, right? 0.5. Okay, and 0 to 2 I can also move. So if I move from 0 to 2, then what is my success probability? 0.2. Okay, so this is what I'm writing here. So from 1 I can move to 0 with this success probability. From 1 I can move to this 2 with this success probability. Okay, and then from 2 I can move to this node with this success probability, and from 2 I can move to this node 0 with this success probability. Okay, so let's first write this step in our code. Okay, so here this is going to be my code, right? So let me just maximize it. So here first thing that we need to do here, we have to create one map. Okay, and in the map what are we going to store? We are going to store this as my key, okay, which is nothing but int type, right? And then after that we are storing these two values, right? These two values are nothing but, this is one list, and in the list we have two values, right? Two arrays. Okay, so let's say this is one array value and this is one complete array value. Okay, and I'm just going to say that all the values in my array is going to be of double type. Okay, so let's do that. So map, here integer, and here list, and in my list we are storing the values in double. Okay, so this is nothing but double array. Okay, array. Okay, and let's name it as graph. Okay, and here just write new hash map. Okay, this is done. Then let's iterate over all the edges one by one. Okay, so here I'm simply going to use a for loop. Okay, for int I is equal to 0, and we have total 3 edges, right? So I is less than n. Okay, and I plus plus. Okay, so here I should give it edges dot length. Now there can be multiple edges. Okay, edges dot length. Okay, and here inside this what I have to do here, int u. Okay, so u is given at this position, right? If I just go to this edges, so this is nothing but my u, and this is nothing but my v. Okay, so u is at index 0, this v is at index 1 of a particular edge. Okay, let's say this is my edge. okay, single edge. So here I have to write into u is equal to edges of I, okay, and here 0, okay, and same way int v is equal to edges of I, okay, 1, okay, at 1 we have this, right, at 0 we have this, okay, this is done. Now from u to v we are moving, right? So here success probability also we need to store. So here let's do one thing, double probability, okay, and here success, from here it is coming, right, success probe, from here it is going to come, okay, this value success probe of I, okay, this is done. Then here we have to construct our graph. So here I'm going to write graph dot compute if absent, okay, and here first u, okay, and then after that I need to write if the value is not there, okay, for this key, then I am just going to create a new array list, okay, if this key is not there initially, okay. But if this key is already there, then we don't need to do execute this step, okay, then we have to simply add that, okay. If it is not there, then we have to create one array list and then we have to add, okay. So what are we going to add in this particular key? We are going to add one here, see, we have to add these two values, right, these two values, right, like this. So what I'm going to do here, add, and here new double array, okay, double array we are going to add, right. So in double array I am adding two values. So what are the two values that I am adding? Okay, so first 0 to 1, let's suppose I am moving, so I have to add this array, okay, this array. So in this array what are the two values? First is nothing but my edge, okay, v, where I am moving, okay, and this is nothing but my probability, okay. So this is what I need to write. So here I am going to write v, and here I am going to write prop, okay, probability, that's it, okay. And since this is undirected graph, so since I can move from u to v, I can also move from v to u, okay. So here let me just write it like this. So here instead of u write v, and here I am going to write u, okay. This is done. So this is going to be our first step, okay, that's it. So we have constructed the graph. Then our next step is going to be initialize the max probability array and priority queue, okay. So let's move to our next step. So initialize probability array and priority queue, okay. So we have to initialize an array max probability to store the maximum probability to reach each node from the start node, okay. So from start to start itself 100% probability we have, okay, we can definitely move. So I'm going to write 1.0 here, and all other values I'm just going to initialize 0.0, 0.0, okay. So see here, if you go to the constraints for this problem, you will see that here probability, success probability ranges from 0 to 1, okay. So this is what I need to do here, okay. So let's do that. So here double, and max probability is equal to new double, and here just write n, right, and we have to give the max probability or at first index, okay, from where we have to start. So we are starting from this, so this I need to set to 1.0, right. So here I am writing max prob of start is equal to 1.0, okay, this is done. And then after that, see here we have to use the priority queue, right. The priority queue max heap starts with the start node 0 and a probability of 1.0, okay. So this is what we need to do. We need to add this in the my priority queue first time. So here I am going to write priority queue, okay, priority queue, and inside this we are passing the double type array, okay. So here, okay, this is what I need to pass here. Let's name it as pq is equal to, and here since this is my max heap, okay, so I have to write it like this, new priority queue, okay. And inside this, let's say if I have two parameters, okay, two different arrays or parameters you can say, then I have to compare them based on their first value, okay. So here double dot compare, and I have to compare them based on their first index, okay. So for let's suppose that from B, let's pick one index, okay, and from A let's pick the value at index 0. Okay, this is how we need to compare. Okay, so and in my priority queue I have to add initially my start. Okay, so priority queue dot add, so here new double. Okay, array we need to add. So here what are the two values of the array? So here first thing we are I'm going to add the probability. So this is going to be my probability. Okay, if I am at this start. Okay, so from start, if I want to move to start only, so this is going to be my probability. Okay, that's how you can see it. Okay, so this is done. So this is going to be my step 2. So step 2 is nothing but initialize the max probability array and store the maximum probability to reach each node. Okay, so from start I can reach start in just 1.0. Okay, max probability. So here I fix this, and other things I don't know right now. And the priority to max heap starts from the start node 0 and a probability of 1.0. so here I'm writing probability, and here I'm writing start. Okay, then after that what we need to do, that is going to be nothing but my step number 3. Okay, so in my step number 3 I have to run one, we have to process the nodes in order of decreasing probability. Okay, so here first thing we have to pop this from my priority queue. Okay, so let me just write here one while loop. Okay, so while my priority queue is not empty, so this is going to be my step number 3. So while my priority queue is not empty, pq is empty. Okay, so now inside this we have to write my code. Okay, so here it should be pq dot is empty. Okay, so inside this I need to write my code. So first thing we are doing here, we are going to pop this initial value from the pq. So here what I'm going to do, I'm going to write it like this, double. Okay, so this is going to be my current values in my array. Okay, so double cur, let's name it like this, and here pq dot poll. Okay, so I have polled it. Okay, I have removed it from priority queue, and there are two values in this. So I am going to say that this is my current probability. Okay, current probability, and I am going to say this as my current node. Okay, so let's do that here in my code. So double current probability, curp current probability. Okay, so here this is at cur of 0 index. Okay, and also I need the current node. Okay, so here int cur node, but in my this is my double array, so all the values are in double format, right? So I need to convert the value at cur of 1 to int. Okay, because here I'm taking the int variable. Okay, for the node. So here let's just do the cast here. So int. Okay, this is done. So now after that, once this is done, so here one base condition we need to do here, if my current node is equal to the target. Okay, then in that case simply return. Okay, so here let's add that step first. If my cur node is equal to end, then simply return. Okay, return cur node. Okay, so here simply return cur probe. Okay, so let me just name this as, okay, int n, then we have int edges, then we have success probability, then we have int start. Okay, so here let me just give it like the start and end. Okay, it is much easier to understand like this. Okay, so this is done. Then after that, after this, so we have to run one loop. Okay, so here first let's understand what I'm doing. So pop this, current node is 0 and current probability is 1.0. Then we have to visit the neighbors of node 0. So what are the neighbors of node 0? 1 and 2. Okay, so first let's visit neighbor 1. So in neighbor 1, what is the probability? 0.5. Okay, so new probability to reach node. Okay, so 0 to 1 if I'm moving, here my probability is 1.0, and here 0 to 1 if I move, then probability is 0.5. Okay, then the total probability to reach at 1 is nothing but 1.0 into 0.5, 0.5. Okay, so new probability to reach at 1 is this one, and then we have to update the max probability at 1. Okay, so max probability I am going to update at 1 is 0.5, and then we have to add 0.5 comma 1 to priority queue. Okay, this is not one probability, this is nothing but my node. Then we have to visit the next neighbor of this 0 node. So next neighbor is 2. So here I visit this neighbor, edge probability is 0.2. So at 0 we have probability 1.0, and I am moving to node 2. Okay, and probability to move from 0 to 2 is nothing but 0.2, right? 0.2. So total probability to reach at 2 is nothing but 1.0 into 0.2 is going to be 0.2. Okay, so I have to update my max probability at 2 at like this. Okay, so once this is done, then I have to add 0.51 and 0.2 of 1, okay, to my priority queue. This is what I need to do, right? And since my priority queue is going to be a max heap, so this value is greater, right? 0.5 is greater, so 0.5 will come to the top and 0.2 will remain in the bottom only. Okay, this is my priority queue. Okay, so this is max heap. So max heap based on this first value, so this is larger, so this will come first. Then we have to pop this. Okay, my priority queue is still not empty, pop this. So now current node is 1 and current probability is 0.5. okay, then we have to visit the neighbors of node 1. So what are the neighbors of node 1? 0 and 2. Okay, so first I go to this neighbor, edge probability is 0.5, new probability to reach node 0 is 0.25, which is not greater than the max probability of 0, because this was 1 initially, right? So no update. Then neighbor 2 I want to calculate the probability, so edge probability is 0.5. So new probability to reach node 2 from my current node 1 is nothing but 0.5 into 0.25. So max probability I update to 0.25. This is greater than the previous probability of 0.2. Okay, so this is greater than 0.2 is coming here, and here is coming 0.25. So this is greater, right? So we have to add this to priority queue. So now in the priority queue, see here 0.25 comes on the top. Okay, now we have to pop this. So here current node is equal to 2. Okay, since node 2 is the target, we run the current probability which is greater than 0.25. okay, so this is the base step that I have written. Okay, that's it. That's what we need to do here. So let's write the code, then you guys will get more clear understanding. Okay, so for here double. Okay, so now we have to visit the neighbors, right, one by one. So this is one double array, this is one double array. Okay, so double next. Okay, and here I'm using for each loop, simple, right? Graph dot get or default, and here I am passing current node. Okay, and if there is no neighbors, then simply write new array list now, so that we don't go into any errors. Okay, so if it is empty array list, then simply means that we have to end. That's it. So this is what I need to do here to visit the neighbors. So now for this next node, okay, for this next node I have to create two I need the next node and I need the next probability. So I am taking the nodes in int type, and I am taking the probabilities in the double format, right? So next prob. Okay, so here if you see, go to my code. So next node I am storing at this first index, and next probability I am storing at this index 0 1, right? So here write 0 first. So I need it in int type, so int, and here next of 0. Okay, and here it is nothing but next of 1. We need it in double format only. Okay, and then after that I have to compare this now. If my current probability, okay, I have to multiply this to current probability into my next probability. Okay, if it is greater than the max probability. Okay, so here max probability at where, at which position? Max probability at next node. Okay, in that case only we have to do the steps, okay, later steps. If it's not the case, then we have to not do this, right? So this is what I'm checking now. Here somewhere I did written that. So new probability to reach is this, okay, which is not greater than max probability is 0, so no update. Okay, so if it is greater, then we have to update. So if it is greater here, then what I need to do, I have to update the max probability of my next node to the current probability into the next node, next probability. Okay, this is going to be my max probability at this position, and then we have to add this in my priority queue. So here pq dot add. Okay, and what we are going to add, we are going to add the double array, right? New double, and inside this what I need to pass, I need to pass my max probability at next node. Okay, so in priority queue, what are we passing? In priority queue, first thing I am passing here probability, and then I am passing that particular node. Okay, so here max probability at next node, and then I have to pass my next node. So here just copy this next node. That's it. Okay, this is done. Then in the end, step 4 that we need to do here is return 0 if there is no path to the end node. So here simply I'm returning 0.0. Okay, so now let's try to run the code and see if there are any code issues. So yes, so let's try to fix them. So here it should be single R, right? I'm taking car node. Okay, line number 20. Here it should be single R. Okay, let's run it again. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And here see, time complexity. So here I am visiting all the edges. So let's say for this part my time complexity is going to be of E. Okay, then after that here if you see, I am adding the elements in the priority queue. So this I can say that priority queue at this step is going to be of log b, because insertion in the priority queue is going to take of log b time complexity. Okay, then after that I am running this while loop. Okay, so while my priority queue is not empty, so inside this I am doing this poll. Okay, so this is also going to take this time complexity of log b. Okay, and inside this I am running this loop. Okay, so it can go for max all the edges. Okay, so it can go for max all the edges. Then for all the edges we may apply all these poll and insertion operations. So what I'm going to say here, okay, so this could be the case now for all the edges if I visit all the edges, okay, in this for loop, and for all the edges if I apply insertion priority queue add or priority queue dot poll, then I can say that my time complexity for this problem is going to be of E into log v. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.